A tool sits in the spindle. The program calls Z0.1. The spindle dives, the tool buries itself in the vise, and somebody yells. 9 times out of 10, the line that was missing was G43. This is the line. G43 H1, Z1 inch, 3 pieces, and most operators couldn't tell you which piece does the actual work. Start with what G43 is actually compensating. The control knows where the spindle nose is. It does not know how far past the spindle nose your tool sticks out. That distance, gauge line to tool tip, is what G43 applies. Every tool in your carousel is a different length. A face mill might stick out 2 inches. A long reach end mill, 6. The control has no way to measure that on its own. Somebody had to touch it off and write the number into an offset table. That number lives in the tool length offset register, indexed by H number. H1 is the offset for tool 1. H4 is the offset for tool 4. The H, not the G43, is the part that picks the right value. Say that part out loud. G43 turns the feature on. The H number tells it which tool. Mismatch the two, and you get a silent disaster. G43 H2 with tool 1 in the spindle means the control is applying tool 2's length to tool 1's geometry. The program runs. Nothing alarms. The Z coordinates are just wrong by the difference between the two tools. Now, G44. Same idea, opposite sign. G43 adds the offset to the Z move. G44 subtracts it. You will find G44 in textbooks and almost never on a real shop floor. Pick a convention, stick with G43, move on. Here's the before and after that matters. Without G43 active, the control treats the spindle nose as Z0. With G43 H active, Z0 shifts down to the actual tooltip. Same program, 2 completely different machine positions. Now the crash. You wrote a program. You touched off every tool. You forgot to type G43 H1 on the line after the tool change. The program says rapid to Z 1 inch above part. The control reads that as Z 1 inch above the spindle nose because no tool length is active. Your tool is 5 inches longer than that. Walk the sequence. Control commands rapid. Z-axis moves to position spindle nose at 1 inch. Tooltip arrives 4 inches below the table. There is no math step in there that catches the problem. And here's the part that makes this video worth your time. The control will not warn you. There is no alarm for a missing G43. The machine assumes you meant 0 offset. 0 is a legal value. Legal values don't trigger alarms. Most crashes blamed on operator error are actually a forgotten G43. The control gave you nothing. No flag, no prompt, no second chance. 2 habits that fix this for life. 1. Every tool change line is immediately followed by G43 H, matching the tool. Make it muscle memory. T5 MO6, next line G43 H5. No exceptions. 2. Dry run with Z up. Run the program with Z plus 6 inches of offset before you trust it on a part. If the tool tries to dive into the table, it dives into air instead. That's a free crash, and it has saved more setups than any alarm ever has. If you've made it this far, you already understand G43 better than most of the operators running production tonight. Subscribe. ShopFloorIQ does plain English explainers like this on the codes, the parts, and the silent mistakes nobody trains you out of.